Hello and welcome, whether you are in the Zoom meeting or watching from YouTube. Welcome to our third developer community meeting. I am David Yanni, one of your AI leads.
And I'm Pranjali, the second AI lead.
And today we're going to be going over the Kaggle competition that we just had a while ago. Kind of a bummer. There were no submissions. So if you had just submitted the base notebook that I put with a like at least one line of difference, you would have gotten first place. And you would have been a lot closer to that swag. So it's just letting you know what you missed out on. So let's go over to the Kaggle competition in question. It was, this is the notebook, but the actual competition is here on Kaggle. Oh, there's a notebook again. Let me see. It's this competition where you have some data where it's a lot of data about houses, and the goal of this competition is to accurately guess or create a model that guesses the price of the house according to this data that you have here. So Pranjali, if you want to take it away or share your screen, let me know.
Yeah, just give me a second. So are we beginning with the code or understanding?
You can go over the data.
Right, perfect. So over here you were supposed to basically predict house prices based on a number of different factors. If you could just pull up that list of features for us, David.
It's a lot.
Right. So there were a bunch of features. Each one of them had different weights.
We lost you. Can you like higher the volume of your mic in your audio settings real quick?
Sure. Give me a second. Okay. Can you hear me now?
Yeah, a little bit better.
Perfect. Yeah. So what we attempted to do here was based on these different factors, just roof style, land slope, neighborhood, all these around 26.
Oh, we lost you again. Make sure your headset is plugged in correctly.
It is plugged in. I think it's gonna take a while to fix itself. You can take it away. I'll come in.
All right. So, as Pranjali was saying, you have all these data points or features that can come from a house, like the basement, what type of heating, if it has a first floor, second floor, what's the square feet of those floors, kitchen, the quality of the kitchen, if it has a paved driveway, and you would get the values of these features, pre-process them, of course, in order to prevent having null values, which we mentioned in the second developer community meeting. Values that don't make sense because sometimes in the data, there's like, I remember going into this data set that was the data on some bike trips. And some of the ages of the people in that data set were like over 100 years old. And it just didn't make sense for people over 100 years old to be riding bikes for like 3 miles. So you gotta watch out for data like that. And that's what the pre-processing step is for. Then you would have to make a model where you would feed in these pre-processed features. So the one I used in the base notebook that I sent you was a random forest regressor from scikit-learn. And what this is, it's an ensemble model and ensemble is just a collection of multiple of the same type of thing. And what the ensemble here was a collection of decision trees. And decision trees are kind of like, it's hard to explain without a picture. Let me search one up real quick. The AI. And I really recommend this website if you're looking for definitions. Decision trees. And as you can tell, this is kind of more informal, trying to relate, trying to ease you in. So here, it's a supervised learning technique, and it has some predefined targets. Man, this does not have pictures. Let me stop sharing and actually draw it on a whiteboard. Can you see it? Can you see me drawing right now?
Yes. Yeah.
All right, so the decision tree would be something like this. So let's say you have a decision tree for the feature, how many square feet it is in the first floor of the house. So let's say and if it's about, let's say 0, like if there's no square feet or if there's no first floor, it'll go to one branch, and it'll probably say, okay, this house is probably less than $5,000, obviously, and if it does, it's probably more than $5,000. And there's multiple of these decision trees for all of the features, and that's what kind of lets it estimate what $1,000. Let me just have those there, and that's what lets it estimate like what price what the price is according to these features. So let me share all my drawings, stop sharing, share again my screen. All right, so going back to the base. So like I said, you need to pre-process the data that you're working with. And for this competition, there's a lot of it. You can see right here. Let's go into the train.csv. This is the training data that you would be using. And you can see there's numerical, categorical. Numerical is numbers, categorical is strings. And there's also a ton of them. So you would need to pre-process that. And let me show you the edit. So when you create a notebook on Kaggle, you have an option to choose data, and you would add the data for this competition, the house prices competition. See? And then you would add this. Now that you have that here, you can run this first cell in a notebook, which basically sets up that data as input into your notebook. Taking a while to start, but we'll get there. Right. So there's our data. We have the sample submission CSV, a data description, a train.csv, a test.csv, just like what's in here. And we have that in our notebook. Let's import some libraries. Ignore that. And let's import or read the CSVs, the train CSV and the test CSV using pandas. So the fundamental data structure of pandas is called a data frame. And you can think of a data frame as a table. So I'll show you right now what this looks like. So this is the table that we made with pandas using read CSV, inputting the CSV that we have over here. And this is the table that we made with that data. And in a cursory glance, you can see that there's a couple of NaN values here. Right. Oh, I actually have it there. Now, in the base, I actually just selected a couple of the columns or the features and just went off that. So I'll just keep doing it just to show you again what it would look like. Here, I'm choosing the columns, lot area, lot frontage, utility, cell condition, lot shape of all of these features here. And I'm putting them in our new train data frame. And there's also the test data frame. This is made out of the test set, the test CSV here. This is what you're going to be using to evaluate your model, by the way. And you can see the shapes of all of these two data sets. 1,460 rows by 5 columns, and those 5 columns are the lot area, lot frontage, utilities, definition, and lot shape. Now I'm going to be concatenating them. Now, if you had more than 5 of these columns, you would still do this, so it's convenient to modify these columns all in one. So you would put them together in shape. You see that it's 1460 plus 1459. That's 2919 by 5. And if you want, I can actually show it. The head is a pandas function built into the data frame to show the first 5 rows of your data frame. And now I just made a preprocess function that gets the null NaN values and replaces them with 0 in the lot frontage. And I can show you that. Use the pandas docs, by the way. Right. So I'm gonna show you the amount of NaN values in lot frontage. Right. So I got here all the NA values or NaN or null values, and I added them up. So there's 486 NaN and null values here in the lot frontage. And I actually posted this notebook in the Discord before, but let me see. me share this again in Discord just in case. And I'll share in the Zoom chat as well.
Just a question. The next step meeting is next week, right?
No, we have our developer community meetings bi-weekly. You should know this.
Right, but we did postpone our last week.
That was 2 weeks ago.
Oh, all right. Okay.
Right. So we use a simple imputer. And imputing, what it means, it's a statistics term for basically replacing null NaN values. We got this simple imputer from the sklearn library. That's scikit-learn in long form. They have a lot of useful stuff. And you basically just create this simple imputer with the strategy of constant. And this is just gonna, what the strategy is what do you want to replace it with? And we want to replace it with a constant, and we want that constant to be 0. And then we're going to apply this simple imputer to the lot frontage feature column with the fit transform function of the imputer. And then we're going to make it equal to the lot frontage here so that the change appears on the actual DFL data frame. And then we're gonna do a standard scalar. And I remember how I said in the last dev community meeting that neural networks and basically models don't like numerical values that have a lot of standard deviation, which means that they're very far apart. So what this is going to do is going to scale it down so that they're a lot closer together, and it makes it easier for the model to read it. And that's what we're going to do. We're going to do the standard scalar. We're going to fit transform again to the feature column slot area and lot frontage. And now moving on to the categorical data. This is a little bit easier than the other ones. You don't need the sklearn functions or a class from them. You just do write on pandas. You can do get dummies, input the df, and indicate the columns that are categorical. So here is utilities, sale condition, and lot shape. And we would then split those to utilities 1, utilities, or utilities all pub, and whatever other option it has in terms of category. I'll show you right now. All right, so let me show you what that looks like. Right, so here you can see the lot area, lot frontage, they are scaled down so that they're closer together. And these categorical values here, they've been split up into columns. They've been one-hot encoded. So here you have utilities all pub, utilities no SEWA, I don't know what that means. We got the sale condition, abnormal, sale condition adjacent land, sale condition allocation, sale condition families, normal. These are all the different categorical values that were present in the column. And they're just been split out into columns. And what one cog coding is that it's just showing, all right, this is what it is, this is not what it is. So in this first row, you can see the sale condition is normal. So it's telling you 1, this is what it is, and it's putting 0 for every other sale condition, saying this is not what it is. And it does that with lot shape as well. Now you need since we put the training set and the test set together in order to conveniently change it or do the pre-processing, we need to split it back out into their own shapes. So we would get the first 1459 and put that into the train set. This is from 0 to 1459, so it's 1460. And then we get from 1460 to the end, which would be the last 1459 rows. And you can see we got test and training set back. And now we're going to actually use this function called train test split. This is very useful. And we're going to split the data again into well, it's more the training data. We're going to split it into the actual training data we're going to use to train the model and the data we're going to use to validate while the model's training. Right? No, never mind. This is what we're going to be using to validate the model. Actually, the DF test was what we're going to be predicting with our model. Whoops. That was a slip on my that was my bad. But that just proves that you can't know everything in AI. Right, so we're splitting the training set. We're gonna have our X train, Y train. The X train is gonna be the feature columns. And the Y train is gonna be the labels for these columns or the actual price of the houses. And I actually put these labels, I took out these labels from the training set up all the way up here. And I dropped the sale price from the training set because you don't need the labels in the actual train. You need it separate, because if you leave in the sale price, you would get some issues with the shape of the data, and that's also a form of data leakage. And data leakage just means you have the answer in your training data by mistake.
Yeah, meaning that you're training and testing on the same set of data. That's what data leakage is. So your model is not really learning when you have data leakage. So it reduces its efficiency.
Yeah, but it can also be that there's a data point or a feature in your training set. If it was one of these features that really reveals the answer. So let's say there was a data set that had like a data from a patient in a hospital, like the blood type, last time he went to the hospital, how sick he's been, and you want to predict whether someone has a disease or not. If you have a data point in that data set that says been vaccinated, for example, let's say we're talking about detecting measles with a data set, and you have a feature that says has been vaccinated.
Yeah, you have the
and that's
answer right
data,
away.
Yeah, so you have the answer right away. So you're not really training it on the data that you want to train it with, which is the blood type. When was the last time?
Features.
Yeah, you're training it on this data leakage, which basically just reveals the answer.
Yeah, very yes or no type of question.
Yeah.
So yeah, I mean, in this case, you want to like the usual standard is train is 80% and test is 20%. In this notebook, David did a 75% training and then 25% of the data used in testing, and then went ahead and trained it on the features and labels. So the X's stand for each of the features and Y stand for the price.
I'll actually just show the
Yeah.
shape head. And I'll show I think this is a series, but it might be a list. Yeah, it's a series.
Right. So features and prices listed for y'all. Yeah.
And then you would start your model. Remember, this is an ensemble of a lot of decision trees. We can also put in an estimators. This is another. This. Let me actually just have it open on the actual sklearn page then.
So I mean, an estimator is just it finds the
It's the number of
decision
trees in the forest.
Yes.
So the number
to
of decision
improve-
trees.
Right. So optimize, kind of acts as the optimizer function like a regular network.
So the default is 100.
Mhm.
I'm actually gonna increase it to 150. Max def. We can put this. And these are parameters that anyone can play around with. In fact, there are people that do this brute force method. They make a for loop with a bunch of parameter options or values for those parameters, and they should see which model does the best. That's a valid way of doing it. So next step, let's do 50. This is probably going to be TLR. Random state. And 40, and this random state basically says what's the initial weight's going to be, because in Python it's the random is actually pseudo random. So this seed value, this is a seed value here to say, all right, this is the random weights I want. All right, so let's initialize that. And now we're going to fit the training data into those weights. So we're going to train the model here. And now let's predict on the X test. This is the one we split off from the original training set that we're going to use to evaluate the model, see how it's doing. I think before it was pretty similar to this as well. So I don't think it had a big improvement, but we'll see. Now I'm going to create my submission to the competition. We're going to predict on the actual DF test, which is the test we read it a while ago. And we're going to concat the test IDs, which is basically just the index of this test. And we're going to end the submission, which are our predictions. And it is just some mumbo jumbo because I actually forgot to include a column name. just
Yeah,
just to get
Kaggle
that
is
column.
gonna show you your performance on like test cases one by one, and so that's like one of the really good features of Kaggle when you submit it.
Right. Then we can create our CSV. Right. And then if you had done this, you would save your version, version 5, whatever. You would save it. It takes a while to actually save it and run it, but right now you probably want to be thinking about how you can improve what you just did. So something that I suggested everyone do when in the last dev community meeting was just to include a little bit more features. So there's a lot of features and I only included 5. Let me see how many features there are. 81. There's 81 features. I included 5 of 81 features, so that's a lot. So let me include some features here. Let's do console. No. You can actually go into the data description.text here in the competition to see what the features mean. Let's not do that.
I had a question. You started the competition on your name, right?
Sorry, my bad. Can you ask that again?
Yeah, I was just asking. You started the house rising competition, like you started a competition of your own,
Yeah.
right? That's where you're supposed to get submissions. But yeah, I think primarily due to I guess not following up and missing that meeting 2 weeks ago.
Yeah, you know what happened during that meeting? There was also a meeting. I learned about it while the meeting was going on. That there was actually a shell hacks meeting at the same time. And I was like, oh man, that kind of ruins it. Right. So here's our version 5. We can open it in the viewer, or we can submit our output, our submission to the competition, which we're going to do right now. Submit. You can view your submissions. That's actually lower than what I had before. Maybe this is the part where I go back and change it back to what it was before. Let's see, where is it? Here. All right, so maybe 150 wasn't that good. Where's that model? Here. Right, but you know what is gonna help? Putting more data. So I see a good 2 good data points here. Overall quality and overall condition. These are really good data points that will probably help us a lot. So let's include them.
For every submission, you're gonna get a public score, which basically when you submit on Kaggle, they test your model on like 25%, 30% of the data, and I think that's like it doesn't mean accuracy. It's a bunch of factors mixed.
Yeah, in this case, what they're testing right now is mean squared error. I'm pretty sure they actually have it in the overview here how it's going to be evaluated. Yeah, root mean squared error, and they get it with that. Right. So this is all you had to do. Overall quality and overall condition, right? Overall condition. I'll put that over here as well. Let me reset it. So now I have overall condition and overall quality in both. One thing that we do have to do though, you can either go over here to the data and search for the column here. And then look at the data from here. Or you could actually just go over here. I'm going to be looking for null and NaN values. So I could just go. It's better if I can cap it first. Right, I'm just going to be doing the same thing over here. Or overall quality, overall condition. And the notebook, the default thing that it does is print out the output below. But if you want to do multiple, if you want to print out multiple things in the same code cell, you have to use the print statement. Finish. Here's our 2,919 rows, which are 7 columns. We got our overall quality and overall condition here. Let's see how many error. Okay, so it has no NA or NAT or no values. That's pretty good. They're also the numbers are actually pretty close together as well. From the data description, you can see that the numbers are 1 through 10. That's very close together, so we don't need to scale them down. It's optional, but you don't need to. Let me see if I can actually list out the unique values from here. So you don't need to. So I can show that you don't need to go to the actual competition page to see what the values are.
Just very sorry. I'm gonna have to take off. I have a very important meeting in a few minutes.
All right.
Yeah.
Goodbye, Pranjali.
All right. Goodbye, everyone. Please submit. Try this project. If nothing, it's just gonna improve your skills. You know, as you learn AI, start learning AI. So yeah, I'll see you next week. Bye. Bye. And yeah, please make sure to come to the general body meeting on Friday. Try to come. But yeah, that's it. Bye.
Bye. So you can see you have a couple more numbers in overall quality than overall condition, but that's okay. Actually, you know what? Is it okay? I think not. I was just add them. No, it's okay. Random forest is pretty good. at taking in a lot of strange values, so it should be fine. But if it was a neural network, I would probably want to scale these down just in case. Train. Got a Y train model. And this is all you had to do. You just needed to add a couple of columns and pre-process them. And that's basically what you just do in ML. You get a bunch of data, pre-process it, make a model, evaluate it. If it's doo-doo, you need to do it again or change something. If it's not, don't touch it. If it ain't broke, don't fix it, you know? All right, we're gonna train our model. It's a lot, it doesn't start with a 4, so that's probably a big improvement, hopefully. We're gonna create our submission. Let's save. And as Punjali said, I really can't recommend doing Kaggle competitions or just being on Kaggle, getting whatever data and doing your own thing with it. Because if you don't get hands-on experience, you're not gonna learn. There's only so much that courses on Coursera and YouTube can teach you. But in order to actually be good at coding ML, you actually have to get into it. It's a lot, but the good thing is you don't need to know everything. You just saw me look up from the documentation. So of course you can do the same. Submit to the competition. Oh, it actually did worse. Oh wait, no, that's good. Oh, right. My bad. So actually, the lesser the score, the better, because that means you have a less error. So you're actually doing pretty good. So if I jump to my position on the leaderboard, hey, there I am. So let me actually close and pin that. And you can actually have the link right here that you can go into. And you can just do the same. Add a column, pre-process it. If it's numerical, scale it down using the standard scaler. If it's categorical, put it into the my bad, coming down with a cough, not COVID though. If it's categorical, you put it, hold on, where's my pre-process? If it's categorical, you put it into your prefix here. So you get the utilities, and you put it into the column so that it takes into consideration. I only have 10 minutes left, so I'll just do one categorical to show you how that goes. Right, so let me get a categorical. Let's see, good. All right, this is a good one. Exterior quality, exterior condition. Those look like good features that someone will be looking at. Oh, and in Python, you can actually do / and enter and have another row. All right, so let's get those data sets. And exterior condition. All right, let's reset everything. Run this, this, and this. So you see now we have 2 more categorical columns. And you can either go into the train CSV over here and look up if it has any missing or null values, or you can find them from in here, which I'm going to do. And the reason I'm not pressing this play button, you can actually run a cell using Shift Enter in this notebook. Combine them. Now let's see if there are any null or NaN values. No. Perfect. So let's see what are the different types of. You can actually see this in here in the data description as well, but it's nice to be able to see it from the code in case you don't have a nice data description text file like this. Exterior quality, condition. Did it right, wrong? Yeah, I forgot an E. So here are the different categorical values it can be. And the good thing about combining the training and the testing data is that if in the training data, there's certain categorical values and that are not in the testing data, you can still take them into consideration if you combine them and do the pre-processing together. All right, so let's get our exterior quality and exterior condition in here as prefixes. And let's take them into consideration. Let me actually do that / trick again. Pre-processing. Exterior condition index. Did I put in another typo? Yes. Right. See now that we have external quality and all the different things it could be. Now let's split the data sets back. Split the training set into the ones we're going to actually train the model with and what we're going to use to evaluate it with. Our labels. Let's initialize the model again. Let's fit. Yeah, I don't know why that's like that. Right. Let's save our version. And again, I highly encourage everyone that's watching to either get on this notebook that I sent in the Discord to modify the columns, add more columns that you think would be interesting, or just add all of them and pre-process everything and see how you do. I just showed you how to add numerical, and I just added a categorical. And if you don't like this competition, you can just get whatever data set is on Kaggle. In Kaggle, you can just go into the data sets and just find your own data. Create a notebook and add it in. All right, so let's submit this to the competition. See how it did. See how those categorical values changed. Change it a little bit. So that's pretty much it. So to summarize, oops, let me add meeting controls. I showed you what the original base notebook was doing. I showed you how to add numerical columns. And the numerical columns I added were overall quality and overall condition. I showed you how to add categorical columns and how to pre-process those. And then I showed you how we fit or trained a model to predict, and you saw how the model predictions actually improved the more data you added. More data, better model. That's the same. If you want to actually do it with a different model, let's say a neural network, you would need to use the Keras API from TensorFlow to do it. And you could probably get away with not scaling down these overall quality and overall condition features, but I would probably put them in the standard scalar area. Right. So that's pretty much it. Get on Kaggle, get on this notebook, explore how you add new features and predict and get and submit it into a competition so you can get a score, get on the leaderboard. The Kaggle competition in terms of the points for the deaf community, it's pretty much over. The next one is gonna be after I teach you guys computer vision, which is gonna be and computer vision is gonna be the next developer community meeting. Right. That's pretty much it. If there are any questions, actually, let me show the slide with the Discord QR code. If there's any questions, feel free to DM me on Discord at Daver right here. Thank you for coming. Let me end the recording.